Hello, my name is Gunnar Oldenburg, and today we're going to be going over the gyroscopic principles, rigidity in space, and precession. So let's start with the basics. What even is a gyroscope? A gyroscope is a small metal device found in many of our flight instruments that works based on the two gyroscopic principles, rigidity in space and precession. The building materials vary, but in aviation they're generally constructed with aluminum or stainless steel, due to them being relatively lightweight and durable metals that resist wear at high speeds better than other metals. Here we have a gyroscope inside of a heading indicator. You can see some of the main pieces of the gyroscope. Here is the main rotor. This is what's actually spinning inside of the gyro. And we have the gimbal cage, these two circular discs around the main rotor that allow it to rotate freely inside of the instrument while the airplane moves about. So what is the principle of rigidity in space? The principle states that a gyro in motion will resist change in any direction as long as it's spinning fast enough. This is of course assuming that there are no outside forces that are acting on it. That's because of Newton's first law. An object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. Think of a bicycle. How come it becomes more stable and easier to ride the faster the wheels spin? Well, that's exactly how rigidity in space works. So here I have a picture of a man riding a bicycle. The faster, as all of us I'm sure have ridden a bike before, the faster you pedal, the faster your wheels spin, and they generate that gyroscopic inertia. And because of that, they resist directional change and they want to continue forward, which creates the stability of the bike you're riding on. So then what's precession? Gyroscopic precession states that any external force applied onto the gyro will be applied at a right angle, 90 degrees from the point of where the force was initially applied. This is because of the force resisting directional change in the gyro, rigidity in space, or gyroscopic inertia. This force felt on the gyroscope is how we produce the readings on many of our instruments, such as the heading indicator, turn coordinator, and attitude indicator. It is a combined effort of these two principles that give us our readings. So here I have a picture of the gyro's rotor. Here is spinning. The force precision states that the force that is applied on the gyro, because of the gyroscopic inertia, the force is actually felt 90 degrees later because of the initial resistance of the gyroscope. So we would actually feel the force here. So how does a gyroscope actually work? What parts make up the gyroscope? How does it produce readings? So we have a few of the main components of a gyroscope. We have the main rotor here, which is the main piece that's spinning, resisting the change in direction. So this is the piece that's actually experiencing rigidity in space. And then we have the gimbals, these two circles that are caging in the rotor, and that allows the rotor to spin freely in space while the rest of the gyroscope is moving with the airplane. So we have precession. When our plane adjusts the direction of travel, this force is applied 90 degrees to the initial point on the spinning rotor. This helps us determine our readings on the instrument. So let's just say that the airplane is going into a climb. The gyroscope is going to feel that force at any given point, but it won't actually be applied until 90 degrees later because of precession. Indications. Due to the rotor being able to freely move within the gimbal cage, the instruments get readings by comparing the direction of travel of the airplane and the direction of rotation of the gyro's rotor. So how do we actually apply this to aviation? Many of our flight instruments have a gyroscope inside them. The instruments get their readings by comparing the airplane's direction of travel relative to the direction the gyroscope is spinning in. Our instruments that require rotational or directional readings use gyroscopes. Because of rigidity in space, the gyroscopes will continue to spin in the direction it began in, but that's only half of it. Our instruments are able to indicate changes in direction of travel with the help of precession, as we know that wherever the force on the gyro is felt, it's actually applied 90 degrees behind that point, or ahead of that point. This is how our instruments are able to indicate our aircraft's positional changes. So of the six-pack, instruments that you'll pretty much find in any airplane you'll fly. These are the three that have a gyroscope inside of them. We have the attitude indicator, heading indicator, and your turn coordinator. So in conclusion, the key takeaways: the instruments get their readings based on the direction of the airplane's travel relative to the direction the gyro is spinning in. When the airplane adjusts its direction, such as banking, climbing, or yaw, the gyroscope will experience precision. This is how the gyros knows the change in your flight path. I hope that helped everybody. Happy flying.